So, welcome again, everyone. We are gonna start with, again, James Post. He's an expert on the battery management issue, and he has 12 years of experience in that issue, plus the 40 other years of experience in electronic sector, right? So he's the only one or the most expert person in the field. So welcome, James, to the presentation, and I hope you enjoy it.
I need them.
Hi, that thing. What is that?
Okay, welcome again. Before focusing on battery management systems, I also want to do a little introduction about what are the other important aspects of e-bike technology. And next to battery management, that is motor control. If we make a smart outlook about what are the issues with e-bike technology nowadays, then the most important one is considered to be battery unsafety. The solution is obviously it should be fixed, but the problem until recently was that nobody knew how to fix that. Because we knew that batteries could be unsafe, they could catch fire, could explode, but nobody knew exactly why. And just about 1 year ago, I found out the exact reasons. And when we checked that out further, we just checked many BMS systems and could pinpoint the exact reasons. And those I'm going to mention to you today as well, in addition to what are very important features that most battery management systems don't have today yet. Another example of that is battery longevity. You should know that e-bike batteries have a lifetime of somewhere between 2 and 5 years, and electric vehicles have a lifetime of between 8 and 12 years. How could that be? Well, there are several reasons. One of them is being that electric vehicles are generally more professionally designed and built. Sorry, guys. And the main reason is that e-bike batteries are always charged to 100%. And if you would always charge them to 80%, it would mean that the lifetime is roughly double. And if you charge them to 60%, and I would especially recommend that to you because you said that you charge your e-bike once every week, that's not the smart thing to do. The better way would be to charge them every day, but not all the way. So charge controlling is something that you can do within the BMS. And that will extend the lifetime of batteries till between about 4 to 7 years, considering the drawbacks in design. What we had shown this morning was a presentation about motor controlling, which shows that if you would invest a little bit more in motor controllers by using better switching components, and also by using faster microcontrollers and more precise algorithms, then you can save in total efficiency and gains by algorithms about 8%, which is more than the additional cost of the higher end components. So in other words, there's a lot of improvement possible in this field. And the good news is that I am a consultant that always does that. If you take a look at the reasons why things sometimes go wrong, that people make too cheap choices, that's usually because people look at it with a very narrow view. They look at what's the cost of this motor controller, what's the cost of that motor controller, and then asking to people that don't really know the difference, what's better with that one, and then they maybe cannot give the right answer, and then the manager decides, okay, take the cheaper one. If we talk about BMS cost cutting, well, worse, that can be a safety issue. I will explain the details why that goes wrong. And also, sometimes it can be very important to know more exactly, for example, what is the remaining capacity of the battery when people are driving and the display goes like this, then they have no real idea about how long they can still drive. And by a feature called column counting, you can do that exactly. And then you can even see on the display, on position 1, you can see I can still drive 32 kilometers. Okay, miles, sorry. And in the next position, you can do, for example, 20 kilometers, and in number 5, maybe only 8 kilometers. That is easy for the customer to see how long he can still drive. Okay, so far I was giving some critical notes about the e-bike technology, but it doesn't mean that everything didn't go right. The e-bikes by themselves have gone very far in becoming much better. And if we look at only the batteries, we can say that the lithium battery cell quality and capacity went up and the price went down, so that's positive. And in the high end, I can also say that the safety of e-bike batteries usually is quite good. There is a reason why you will not easily hear about e-bike accidents using Bosch batteries, because they know how to design. What didn't go well is, as I already touched about it, in the low end, BMS saved on the so-called transient protection system. That means that there are voltages that are around, for example, by lightning or by passing through a strong electromagnetic field. And they take out those components, and that saves maybe 40 cents. But the consequence is that the safety is compromised. Another thing is that most smart BMSs don't even have a self-test, although that is very common for important safety systems to have that. And it's not expensive, but they just didn't do it. And it seems that one designer is looking at the other, and if the first one forgot to implement the safety system, then the second one copies that. So I don't even want to talk about safety monitoring, because safety monitoring is basically the dot on the I. With safety monitoring, you can see the problem is going to happen, and you get a warning before it happens. Yeah? That's the way how it should be. And in electric vehicles, for example, that's the way how it is done. And interestingly enough, 10 years ago at the Battery Safety Conference, I was the one that proposed to do safety monitoring on EVs. Afterwards, I moved to e-bikes because the people in EV companies are too smart that they don't need a consultant. So it's very easy to know what we should improve. We should include the transient voltage suppressors that take care of absorbing those signals. We should put a self-test in all BMSs, and we should implement safety monitoring. Yeah, there we go. The dog gets awake. You don't hear any sound, I think, but this is the man to take out the voltage. And luckily that happened during the day. So in the bicycle industry is well known for always counting every penny. And sometimes there are discussions with groups of people about should we replace this bolt by a cheaper bolt that costs 0.5% less. So it's understandable that the traditional managers from the bicycle industry have no knowledge about batteries and such, so let alone about battery management systems. And they have to make a decision on which BMS we are looking. Well, it's understandable that that goes wrong, but the good news is that to upgrade a non-smart BMS that is unsafe, where they took out the safety components, is just costing 3 to 3.5 euro. And 3 weeks ago, I was a guest speaker at a conference by the Chinese e-bike industry in Guangzhou in China. And when I told them that this was the only cost, they were really flabbergasted. They were saying, "Is it only three euro?" I said, "Yes, really, it's only 20 RMB." And now they have said, but if they say it at the conference, it doesn't mean that I'm also going to do it. But they said they will change it. Okay, the cheapest solution doesn't include communication, but that's okay. That's just a small option.
Sorry.
So then the question is, are the low-end Chinese BMS vendors upgrade doing that? And before talking about will they do that, I will first say, how did it come that those BMSs were designed down and took out the critical safety components? It started out that Chinese battery manufacturers didn't have the know-how in-house to design battery management systems. So so other companies came along with electronic design capability that designed BMSs, and they would supply them to the e-bike battery manufacturers, who in turn supply them to e-bike vendors. What happened is that the BMS vendor that was selling best thought, hey, I can make some savings by taking out these safety components. That can't hurt. And that way he saved about 3 euros. And because the cheapest is the best, everybody was moving to that design. So for them, it was the difference between 3 euro and 6 euro. So they made a very big improvement. But of course, for the manufacturer of an e-bike that is costing, for example, 150 euros, those 3 euros don't make a big difference. At 2%, and they say they will change it, but we have to be on top of it before it really happens. The good news is that the China Bicycle Association, which is the trade organization for the e-bike manufacturers, they have already assigned 2 executives to form a task force to invite people for a workshop where the battery manufacturers are being told by me and the Chinese that speaks better Chinese than me how to do the upgrade. As you can see, my presentation there was in Chinese because I know that real-time translation doesn't work. And many people, especially managers that are older, do not speak English. So that was the story about the safety. And if we see in China, there are more than 1,300 e-bike fires and explosions. And that's a figure that's not guessed, but it's registered by security cameras. So that means it doesn't include all the accidents at home. The one we saw just during the day, but also the ones that happen during the night when people are charging their batteries overnight. In New York, where I'm going to be next month to talk to the safety officials, they have 2 persons per month that die on average from e-bike fires. And now in New York, they already have said all e-bike batteries must be UL approved. But that doesn't really help because UL approving means that maybe it will be safe to the touch, but not safe for the electronics. And I spoke to one of the higher people at Brompton, and they said we had to stop selling our e-bikes in New York because we have to comply with UL first, and that's going to cost a lot of money, a lot of time. But those cowboys that are importing 1 container of e-bikes from China, they don't care about UL approval. Maybe they would even put a sticker on there that is UL approved. Who cares? So in any case, the Chinese are well aware of the problem now. Everybody knows, and I hope they will comply in the follow-up, and I will also chase them for that. Safety monitoring is a much more advanced system. It does not look at is the situation unsafe. It predicts when the situation will become unsafe.
Uh,
For example, imagine that in a normal situation, the temperature of the battery cells is going up gradually and slowly. Well, when there is an anomaly, it can happen that because of some impurity of within the cell, that there are short circuits and the battery goes down very fast. Then you can see that in function of time, the temperature is rising much faster than before, and that means you can predict when it will be critical to switch off the battery. And that, as I said, is the dot on the I, and can also be implemented by e-bike batteries. Currently, no e-bike battery has that, even though I'm talking every year since 9 years at Eurobike that they should do that. And now I start to have presentations about it, but I do just like the Roman senator, that after each senator meeting, he would say, and Carthago shall be destroyed. So after each presentation I have about all kind of other battery-related subjects, I always say, and battery safety should be improved. I already mentioned in the introduction that the accuracy of the current battery capacity in e-bikes is not very good. That's even an understatement. I should say highly inaccurate. And Coulomb counting, that you count the energy, is of course much better. And you don't even need to add extra hardware for that. Okay, you can. Then you just spend an extra $3, but you can also do it by doing it in software in a little faster microcontroller. And that's the way how we do it, of course. So many people want that. I have once been at the consumer trade show and asking them, what's your feeling about your capacity indication? And I'm not going to repeat the reactions because they were not very polite. So they really want to have improvement on that. Charge controlling, as I mentioned earlier, means that by letting the user decide how much to charge, you can significantly increase the lifetime of the battery. And how we do that? Well, every battery has a button, and if you push the button longer than 2 seconds, then you tell to the system, I want 100% charging. How often do you need that? Basically only when you need to go on a long trip. Otherwise, when like her, you go on a very short distance, then you just leave it on the default position. And very often 60% is okay for that. And if you do that, then your battery will easily reach 7 years of capacity. Of course, charge controlling and charge percentage is not the only thing. You can ruin the cycle, you can ruin the lifetime also by making a very bad thermal enclosure design. When I do consultancy about that, I often find that people prefer plastic over aluminum, although plastic doesn't conduct the thermal so well. But they could improve that by just adding some additives that conduct the thermal energy. But they don't do that. They don't think about that. And this is why I'm always advising people what to do. Okay, I already mentioned this, and since we are running over time, I don't repeat that now. This is important to know that if you are an e-bike manufacturer, then and you import the batteries from China, and it is not a smart battery, then you should tell your supplier to let him upgrade. Take a photo of this sheet or send an email to get a copy of this presentation so you know what to do. Same for e-bike dealers. When you have an unsafe battery, and you can recognize that when there are less than 4 pins on the charge connector, then very possibly it could be an unsafe battery. For consumers, it's the same thing. Okay, sorry for being a little bit too long. The problem is I know the subject too well, so I tend to talk too much.
So it's been really interesting. So yeah, right. So we are gonna say thank you to James. Thank you for the presentation. And there, somebody has questions. Anybody there? No? Yeah.
So yes, you talked just on of battery management system, how to improve the battery management system. I wanted to ask if you cover also the issue with critical raw materials and the fact that lithium batteries should be overcome in the near future by next generation batteries. So
Do you mean LFP?
not LFP because they have lithium in it. So
Oh,
do
you
you
mean-
contemplate next generation batteries?
You mean like the natrium batteries?
For example, sodium batteries.
That's the same. It's
sulfur
natrium and sodium
batteries.
is the same.
Sodium-
Well, no, I'm the correspondent for Bike Europe about battery technology, and I recently made an article about the future of natrium or sodium batteries, and definitely this will be a great future, but not yet, because currently the weight of the batteries is too much, and
right.
but it will come. Maybe 3 years, maybe 4 years, but for now, although many manufacturers still choose NMC because the perception is that that LFP is too heavy, and they are indeed still a little bit too heavy. But since they have a bigger form factor, like with NMC, you have 18650 or 21700, and that's the maximum. But for LFP, you have, for example, 140, which is 33 millimeter by 140 millimeter, and they have a gain in the power to weight ratio, which means that the total difference when you look at it from the battery point of view for one pack to another, that's only about 6 to 7% now, and that is like 100 something to 200 something gram, and that's acceptable.
Right. The sulfur batteries have much higher density. So I wasn't speaking about sodium exactly, but sulfur sodium.
Yes, I suppose you are talking about sodium
you.
batteries because you think about cargo applications, and it may indeed be true that since cargo bikes are not so critical on the weight of the battery, still critical but not as much as for a regular e-bike, then it could be that they could be implemented about 2 to 3 years from now. And be sure that we follow that. And by the time that they come, our battery management systems will do that.
Anyone?
So again, if you have questions that you come up later, which is very common, mark down my email address or make a photo.
We have just one.
Yeah, and you can also see me at the starters pavilion over there. It's not very appropriate because I'm not really a starter, but but I'm there.
Yeah.
Yeah.
Thank you for your presentation. I have just one question about the cell quality itself, because you talk about the BMS, but what about the cell itself? How to check if the cell is has a right quality or?
Yeah. Okay, if we're going back to the beginning, then I mentioned here that lithium battery cell quality has improved tremendously. If you look at when I came into this industry 12 years ago, it was really terrible, but now it's better under control. But I should say to that it is very well possible that companies order lower grade battery cells that are going to degrade very much faster. But with a good battery management system, you can monitor on a continuous basis. That's why safety monitoring is so important. What are the individual cell voltages? And as you also know, the current that is going on at that time, you can also calculate the impedance or the internal resistance, as most people know that. So yes, it's absolutely possible with a good BMS to monitor whether the cells are still going okay. And in general, I can say that even the Chinese cells, they have improved tremendously because when the Chinese government made a 5-year plan, as they always do, to make sure that there would be a big switch from lead acid to lithium batteries, they also made an arrangement that the Chinese would use machines from South Korea, basically the same class of machines that they use for Samsung, for example. So the days of that Chinese battery cells are by default bad. These days are over. That's why that went well. Okay, thank you for your attention, and I hope that you learned something from it.
Thank you very much, James, for joining us today. Yeah.